Problem number 1.31. In this problem, a ball starts falling on an inclined horizontal plane which is making angle alpha with the horizontal, and this ball is falling from height h on this plane. Okay. And after falling on this ball is rebounding elastically. Okay, in this direction. It is rebounding elastically, and we have to find out the distance from where it will impact for the first time and then rebound. So we have to calculate this distance. Okay. So as it is saying that it rebounds with the elastically, so the speed of rebound would be same with which it will strike this ground. Okay. Now if this angle is alpha, okay, so this angle would also be equals to alpha, and we know that this line is perpendicular. Okay, so this angle and this angle is equal. Okay. So we can say this total angle is 90 minus alpha. So to solve this problem, we have to change our axis. Let's assume this is x-axis and this one is y-axis. Okay. So first of all, we have to convert our gravitational acceleration g along these two planes. This problem is a bit different from ordinary projectile problem. In that case, the horizontal acceleration is equals to 0 and vertical acceleration is g. But in this problem, we are shifting our axis. Then we have to calculate new acceleration. This angle from our right angle triangle, this is 90 minus alpha. So we can figure out two components. One is g cosine alpha, and according to our assumption, this is acceleration in y direction, and you are taking upward side positive, so we can put negative sign here. And in this direction, second acceleration, that is ax, is equals to g sine alpha. So now we already calculated the acceleration. So let's see the velocity component. There are two components. Okay. So from this you can see Vx would be V naught cos 90 minus alpha. It means Vx is equals to V naught cos 90 minus alpha, that is equals to sine alpha, and similarly Vy is V naught sine 90 minus alpha, that is cos alpha. So let's assume that this ball strikes this plane again after a time interval t. Okay, so we can use basic equation of motion, that is s equals to ut. Here we are using in y direction, so we can write uyt plus half ayt square. Okay. So when this ball starts bouncing back, then your height is 0, or y coordinate is 0, and when it will strikes back here, again y is equals to 0. Okay. So we can put here 0. Uy is our v naught cos alpha, v naught cos alpha into t, and ay is minus g cos alpha, so it can be 1 over 2 g cos alpha into t square. Here you can see that this equation would have two solutions, okay, because it is square in t. And first solution is t equals to 0. Second solution is 2 v naught over g. Okay. So t equals to 0 for this point when your y coordinate is 0, and t equals to 2 v naught over g for this point when y coordinate is again 0. Now we have to calculate this displacement along x direction, that is coordinate x. Okay. So again we can apply equation, that is Sx is equals to uxt plus half axt square. Okay. So ux is v naught sine alpha, time is 2 v naught over g twice as. So initial velocity is 0, 2, acceleration is g, height is h, and this is v naught is square. So from here you will get v naught is equals to root 2gs. Now we can substitute this value in this expression, and from here we'll get 8 h sine alpha, as g and g will get cancelled out. So the next point of rebound would be at 8h sine alpha, where alpha is slope of this inclined plane. So this is final solution of this problem.